Welcome to Lab 5 Wildfire Risk Assessment. Here is your mission. Now that you have your LCP files created, you're asked to produce projected fire behavior output for these three scenarios. No treatment, but corrected for current conditions, with the completed slopes units in place, and then with the future slopes units in place. You're asked to report on whether the current and future slopes projects are expected to reduce the burn probability, flame length, and average fire size inside and outside of the treatments. You will deliver these findings to the project stakeholders, and they will decide if additional money and time should be devoted to this endeavor. So, no pressure. The first thing that we're going to do is just get a basic understanding of what your computer abilities are. You might not know much about computers, which is totally fine, but one thing that you should know is whether your computer has a lot of capabilities for processing or not very many. The reason that that's important for this lab is that we're going to be running through some computations in a program called FlamMap, and those do take some pretty decent computer requirements. So things like RAM, storage, memory, and processors are all going to be important in making sure that FlamMap runs successfully. And because most of you might not have a lot of control over the type of computer that you have, we will make the outputs available for those that aren't able to complete the runs in FlamMap. But something to keep in mind as you're running these is try and reduce the amount of other things that are going on in the background. A lot of things on your desktop, like these programs that might be running, might be good to remove those, or checking into your computer system abilities and doing what you can to free up some space on your computer. So we've already built our LCP file. And now we're going to be using that LCP file to run in FlamMap. So let's take a moment to talk about what FlamMap is and why we're using it in this class. Our overall objective, remember, for this assignment is to figure out whether the slopes treatment project was effective at reducing the potential fire behavior. To do that, we need to understand what the potential fire behavior is in our three treatment scenarios. If we can show that there is a change between these different treatment scenarios, then we can show that this field treatment was potentially successful, or depending on what we find, potentially not successful. So it's important that we have accurate inputs, or those inputs being our surface field vegetation from our LCP files, and then we get these outputs. Now, of course, the outputs come along with their own set of assumptions because we're using fire behavior models to say what the fire could certainly behave like when we do our FlamMap runs. But the point that you need to remember is that you're using this other program called FlamMap to produce additional rasters that describe the fire behavior on the site. So through Landfire, you acquired the surface fuel vegetation characteristics layers, these rasters that are about surface fuel, and through FlamMap, you're going to be creating the rasters that you need to understand the potential fire behavior. There's lots and lots of different outputs that you could get from FlamMap. We're only going to be using a couple, but that's why we're taking the time to go into this other program so that we can make rasters and then input those rasters into ARC and do some analysis about the different types of information that those raster values for fire behavior, what different types of information those things contain. So you can either open FlamMap through the Programs folder of ARC Fuels on your C drive, or you can go here to your Wildfire Models, select FlamMap, and when doing this, you'll need to locate it, and it's in under your C drive, in ARC Fuels, Programs, FlamMap 5, and here's the run file for that. Click Close, and it may open up automatically, or you may need to go back to Wildfire Models and then select FlamMap, and it'll open up just like this. So this is the FlamMap program, this is the interface, and this looks just the same as if you were to download FlamMap as an independent program. So the first thing we're going to do is just take a moment to make sure that we have our data organized. Sometimes when you're working on a project, you label things a certain way that makes sense to that part of the project, and then when you're doing something else, you might need to change those names. So to change those names, because it's an LCP file, you can either change them from ARC catalog, or you could actually go to your C drive and change them here without much trouble. So remember, we copied these LCP folders over from lesson 4, and now I'm going to rename 2 of them. So LCP corrected is less meaningful for this part of the project than something like no treatment corrected. And this FMS file, we will work on creating that in the next step. The second thing you want to change is just add a little more detail here. So slopes and then completed 2014, and we will keep slopes target areas the same. Now that that's done, let's go back to FlamMap, and we will create our first FlamMap run. So double click on No Landscape file and find your No Treatment Corrected file. I'm going to make this a little bigger. So you can see this is the LCP file that I created, and it has all the different layers. And to create fire behavior output, I'm going to double select Run and label this No Treatment. And now a fuel moisture file is something that is a really important piece to any fire behavior modeling. So I'm going to take a moment to explain a little bit about fuel moisture files and where those come from and how you can create them and how to make sure that they're the most accurate. Now, running Fire Family Plus is not a part of this class, and if you are interested in more information, I can provide that to you, but I think it's an important background to understand what kind of output we're going to be getting and where that came from. So, quick side note on Fire Family Plus. It's a program that takes historic weather information and consolidates it into various different forms depending on what you're looking for. So I went to a site where this weather information is available, and I downloaded the weather data for the last 10 years for the Bright Angel RAS station, or Remote Area Weather Station. And so first I'm going to import that data and select this FW13 file. Now that that's complete, I see that there are no errors, and so I'll click Close, and I'll make sure to select the Bright Angel RAS station here. So I've got a couple different options. With climatology, you can see average temperatures, precipitation, relative humidity, but I'm mostly interested in the fuel moisture. And so one technique to use to get the fuel moisture is to run a different calculation here. To perform this different calculation, I'm going to go to Weather and Season Reports, and we're looking for percentile weather. And percentile weather is something that we use when we're looking for what the most extreme weather conditions were, and that breaks it down into different categories. And this is useful since if we want to run our fire behavior scenarios for weather that is on the hotter and drier side, then we'll use a higher percentile weather. So we'll click here. And then we have a couple different options here. These are all pieces of what's called the National Fire Danger Rating System, or NFDRS. And although you might not be familiar with the name, I'm sure that all of you have seen the Smokey Bear signs that are around in most forested areas and non-forested areas that show your fire danger for that day. And that's just a measure of what kind of potential fire behavior you would have if a fire were to occur that day, and it influences things like the number of people that are around to fight fires and different planning that might go into effect if a fire were to occur. So we're going to select Burning Index, which is kind of a catch-all. It's a good representation. It's correlated with flame length that we might expect for a fire that day. So now I have my percentile weather. The first thing I come to is that I need to enter a wind direction. And so from my climatology data over here, I was able to look at my wind direction and wind speed and get some kind of an idea on where the winds typically blow from in this area and how fast they typically go. And so I was able to determine that they typically come out of the west. And so then following these directions, I can click calculate number 1, which populates this table, and then I can click calculate number 2, which populates this table, and then done number 3, which populates this table. And so what you get is you have the percentile range, so 98% or 2% of the time it is in this extreme category, and then here's your high category here, 90 to 97 percentile, and moderate and low. And since we're wanting to run our fire for conditions that are potential wildfire conditions but not necessarily extreme, we're going to use the fuel moistures that are in this high category. Now, if you don't have access to more specific site data like this, then you could get some general information on what low, moderate, and high values you could use for fuel moistures. And you can get that from going to this Scott and Bergen publication, and near the top there's going to be some tables for fuel moisture. So on page 8 you can see that we have a table here for your very low fuel moistures, low, moderate, and high for your 1, 10, and 100 hours. And then you also have estimates for your live woody and live herbaceous. So you could just use these canned fuel moistures, but we'll use ones that are more specific to our site. So notice that very low would be in the extreme category, low would be in our high fire behavior category, so it's a little bit different there. But just looking at those numbers, you can see how they compare to what Fire Family Plus is producing, and that they are a little bit different. And so we will hopefully get an increased accuracy in our outputs by using these fuel moistures. So back to FlamMap, we're going to click this plus sign, and we're going to create our fuel moisture file. And so we'll go to Fire Family Plus, and it looks like our 1 hour fuel moisture is going to be 4, and I'll just slide this over. Oh, I won't be able to do that. So that's going to be 4. Put that in here. And 10 hour fuel moisture is going to be, we'll say that's 5. Our 100 hour fuel moisture is going to be 8, which is the same. Our herbaceous fuel moisture is going to be 44. And our live woody fuel moisture is going to be 98. And we can click OK. Now that we have done that, we have this file that's been created. So it's a text file, and you can save this file. So go ahead and save it. And save it as NR_high, so North Rim _high, and that tells us that these are the high fire danger rating fuel moistures. And it'll just add this .fms file at the end, and that makes it available for being used as a fuel moisture file. In the future, if you wish to change some of the fuel moistures, for example, an FMO that we work with occasionally has found that one of the fuel models that he works with has a higher fuel moisture than is typically seen with some of the other fuel moisture, so it's not the same. So going back in and adjusting the fuel moisture for one fuel model might have a pretty significant impact on the fire behavior that he's going to be modeling, and where that fire might be expected to go, or how it might be expected to behave. So these are pretty fluid documents you have the ability to change, and by creating it in FlamMap, it pulls out the fuel models that actually exist in your file. So close that out. And so now that you've created that, you can navigate to where that is. So I'm already in my Lesson 5 inputs folder, and your NR high, and add that in there. And so again, based on information that was averaged from Fire Family Plus, we have our average 20-foot wind speed of 6 miles an hour. And from my climatology section, I was able to determine the rough location that the wind typically comes out from. So from 230 degrees, and our wind speed, so miles per hour at 20 feet, is 6 miles per hour. And so go ahead and click apply. So now I'm going to enter the information that I'm looking for in the fire behavior outputs. So this is going to tell FlamMap what I want to receive in this calculation. So the number of processors should default to whatever your machine has. So mine has 4. The outputs that I want are fireline intensity, rate of spread, flame length, and crown fire activity. And just look at these other ones to see what other outputs you may be able to produce as well. And I'm going to choose the Scott and Reinhardt calculation, so these are just 2 different equations that determine when a fire is going to enter into the canopy. And at this point I'm actually going to, so I'm going to click apply, and then I'm going to launch my fire behavior. We're going to launch our minimum travel time after. So first launch fire behavior. This should take very little time. Okay, so now you can see that we have our fire behavior here. Oops. Now if I were to have kept that window open and tried to rerun minimum travel time, it would have overridden the files that I have here. So because I want to do minimum travel time with a couple different settings, I'm going to do a new run, and I'm going to call this no treatment MTT. And I'm going to navigate to my fuel moisture file and put my winds in 6 and 230, and again apply, and then I'm going to go to the minimum travel time tab this time. So first I'm going to click this radio button for random, and I'm going to put in 2000. This is telling FlamMap that I want to simulate 2,000 different fire starts across my landscape. By doing that, I will run potential fire movement from each of those fire starts, and based on the fuel information that I gave it, it will determine how likely it is that each of those pixels is to burn. So obviously we're not expecting to have 2,000 starts there, but this helps us capture what the burn probability is going to be across the landscape. So areas that have less active fuels or fuel models are going to show a lower burn probability. So the next thing we're going to change here is our resolution of calculation. So we're going to change this to 90. Now the reason that we didn't want to run our fire behavior at the same time is that if we were to run our fire behavior now, it would also change the resolution of that fire behavior to 90 by 90 meters. This is important because later in the lab we're going to be calculating area in our fire activity or fire behavior outputs, and if we had run it with 90 by 90 meters, then it would change the area calculation. So our fire behavior output are 30 by 30 meter resolution, and our MTT are 90 by 90 meters. If we were to run MTT with 30 by 30 meters, it would take over an hour to run. If it's 90 by 90 meters, it changes the spatial resolution of that area, and it runs much quicker. So our simulated time is going to be 360 minutes, so that's several hours of simulation there. A shorter amount of time obviously would be shorter simulation. And we're going to keep this the same. Spotting probability is going to be the same as well. So we'll keep all those the same. And our output is going to be burn probabilities. So from here I'm going to click apply and launch MTT. And this should take about 5 minutes to run. I have a relatively fast machine, and I'm not having to close all the programs that I might have open. If you are not sure about your computer's ability, you may need to close other files that you have open before launching MTT, just to make sure that, or give it a little bit extra chance of running. If you're not able to get the MTT to run, then you can download that information from BBLearn. It is important though, before launching the MTT, to make sure that if you have any documents open that you're working on that you haven't saved, that you save those and maybe close those in case FlamMap shuts your computer down. So that took my computer about 7 minutes to run. So now I'm going to click OK, and so I fast forward a little bit through that, and now I'm going to click close here. So now I've got my 2 sets of output. So I've got my no treatment and my no treatment MTT. I'm going to make this bigger, And I'm going to get ready to take a screen capture of my output. So it doesn't really matter which image you're on. I'm going to turn mine on to burn probability, and I'm going to set things up a little bit. So I've stretched this view out here so I can see the names of these layers. These layers here that were produced are just default layers that get produced when you run the MTT. So I'm going to just double click on one of these runs and pull it to the side so I can see my background layer, and then I'm going to click this pencil button here to show my fuel moisture information and shrink it up also. This is a really useful way to keep track of what inputs you've used when you have created a run. So often you're doing many iterations of the same thing, and you need to have some way to remember what you've done. Mine's not letting me move it there. I'm going to close this out, move it over a little bit this way, drag this again. I want to be able to see what my winds are and what my fuel moistures are. So then you'll use the snipping tool to take a screen capture of this whole area, and that's going to be what you submit on BBLearn for question 1. So now I'll close this out, and now I'm going to be saving these files so that I can move on to my next run. So I'm going to right click on them and click Save As. So these are ASCII files, and ASCII files are files that aren't directly compatible in ARC, so we'll be converting them when we get them in there, but first we need to save them. So we're going to go to our lesson 5 folder, and you're going to create an outputs folder. So I've already got mine here, but you'll go to File, New, Create Outputs folder, and in that outputs folder you will be saving these files. So I'll just create another one for an example. Outputs 2, open that up. And at this point it becomes really important to name these files something that's logical. We're going to be creating a lot of different files from these, and we have to make sure that we can follow this pattern. So I'm going to be labeling all of these NT underscore and then whatever the file name is. So this is FL for flame length, and click Save. And I'm going to do the same thing for rate of spread, fireline intensity, crown fire activity, and burn probability, so you can follow the directions in the lab for that. Once you've saved all of those to that location, you should have your 5 files. So no treatment should have 5 files in it. And now we're going to move on to the slopes corrected for 2014. To do that, we need to first load a different LCP file. If we want to have different results, we need a new LCP file. So I'm going to go ahead and just make a new document here. So this is going to erase everything that I have here, and I'm going to start anew. So, and then click on No Landscape File, and now I'm going to navigate to my Lesson 5 Inputs folder and go to Slopes Completed 2014. And I'm going to repeat the same process. So same input files, label this SL14, and go through those same steps that we did for the no treatment. In the end, you should have a total of 15 files that we'll use in the next part of this lab, which is to analyze the effects or effectiveness of the treatment alternatives. And we'll see that the first step we need to do is go back to ARC and to batch convert our ASCII files into rasters. So ASCII files are something that, although you can see them visually, you can't do any manipulation with them in ARC. So those need to be converted into rasters. So we're going to go to ARC. So before we can start to convert these, we're going to need to add a layer to this ARC project so that we can be given a projection. So I'm going to add some data. And I'm going to add the polygon that I created for the burns that occurred in the last several years. So that was in my Grand Canyon data folder, in my Grand Canyon fire data, fire history, and I'm going to select my North Rim fires here. So this serves the purpose of one, defining those areas, and so I can reference them when I'm looking at my output, but then also it'll give this project a spatial reference. So then we'll go to Tools and Batch Convert ASCII to Raster. And our source folder is going to be our project folder in the outputs. And the first file that we're going to convert is the Crown Fire Activity file. So I'll find all those CFA files and click Select File, and Select File, Select File. Make sure this is selected as integer, and the spatial reference is here, and if we had not added any layer, then there would be no spatial reference as an option here. And our target folder is also going to be the outputs folder. So I'm going to copy this path into this area and then click Convert. So those files were successfully converted. Click OK. So now we're going to move forward with converting the rest of our files. And the reason that we converted the Crown Fire Activity first is that that one was in the integer format, and these other files are going to be in the floating point format. So we'll go back to our batch, and other than the text files, we're going to be moving everything over. And this time we will select floating point, and our spatial reference is correct, outputs folder is correct, and we'll click Convert. So our files were successfully converted. Click OK. Make my arc bigger. So now we have all kinds of files that we just made. I'm going to use my Control button and click my minus sign, and Control and click the check. And that's going to turn them all off. And then I can turn them on when I want to look at them individually. That'll save a little bit of time in loading them each. And so now that we have all of these added, and we can start to do some manipulation. And we'll move on to mapping burn probability and change in burn probability across the landscape. So we're going to be visually comparing the burn probabilities across our 3 different treatments. And to do that, we're going to need to make sure that they're displayed the same way. So the first thing we'll do is we'll look at the values that are in each of those layers and see which one has the widest range of values. So I'm going to do some sorting here. I'm going to slide my burn probability layers all to the same spot. And then I will expand them each and look at their ranges. So it looks like, one, we have pretty low burn probabilities, and that the largest range is with this SL14BP, so the treatment that was done in 2014. So now we're going to stretch these burn probability rasters so they are all covering the same range. That's important because we want to compare them visually, and in order to do that most accurately, they have to be covering the same range. And so to do that, we need to first select which one of these burn probability rasters has the broadest range, and then match the other 2 to that one. So here we have our slopes 2014 burn probability has the broadest range, And so we're going to change visually how this looks, and then we'll change the others to match it visually and numerically. So one way to change the visual stretch here is just to click to left click on the ramp itself, and you can choose a color distribution, and you can select, I'm going to select the rainbow one. There we go. And we're going to want to select invert. So by selecting invert, it makes it so that blue is lower probability and red is higher probability. This is an updated portion of this lab, so the other images that you might see later in the lab will have the red as prominent, but yours should have the blue prominent values there. So let's look at this map. We can see the red places have more burn probability, or a higher probability of burning, than the blue areas. And so now we'll go to our next one, and in order to change this visually and numerically, I'm going to go to Properties, and I'm going to import the color ramp. So this is a nice option if you have done some special adjustments to your color options. You can import it from a different file. This one obviously is pretty straightforward, but I'm going to go to SL14BP, which is the previous one, so that's going to change the color properties. Note that it did change the values here, but it's actually not stretching those values. These are the real values. It's just changing the label. So in order to change the actual values, we need to go down here to Stretch and Type and go to Min Maximum. And I'm going to check the box here for Edit High-Low Values. And I'm going to change this to 8 so that it matches the same values as the SL14. So those all look the same. And now I'm going to click Apply and OK. So now we have this one done, and we'll go over here and do this next one. Properties, just import this for good measure. There we go. And then go down here, Min Maximum, Edit Values, change that to an 8. Click OK. Apply is useful if you're going to do other changes in symbology, but you can also just click OK. So now we have our 3 layers. So I'm going to turn all these on, and I'm just going to click back and forth and see how different they look. So pretty significant changes there from the Slopes 2014 project, and from No Treatment and Slopes 2014. It looks like the 2014 has the most significant change in those numbers. Now, in order to really visually get an idea about this, it's best to compare these side to side, which is something that you would need to do if you were going to be presenting this to somebody. So we're going to go through the process of doing that right now. Notice that when you go to this layout view, it shows you what we see on the active screen. And when you go to Insert Data Frame, you now have 2 frames of reference. So what we're going to do is make 3 data frames, and to each data frame we will have one of these burn probabilities, and then we'll have a table of contents. So now I'm going to add one more data frame. Oops. Insert data frame, and now I have my 3 data frames, and in each of these data frames I need to have one of these BP layers selected. So I'm just going to take this and drag it to this other data frame, and I'll take this one, NT, and drag it to the 3rd one. And now you can see that I have these ones remain. That just was a copy essentially. So I'm going to just turn them off, and I'll turn this one on. I'll minimize these to save space. And now I have, actually I'm going to drag this data frame above here. Then they'll be a little bit more consolidated. There we go. So now I have my 3 data frames. And what I want to do now is arrange this page, because it's pretty messy and I have no idea what's going on if I were to show this to anybody. So the first thing I want to do is change the orientation. So I'm going to go to File and Page and Print Setup and click Landscape. Click OK. So that makes the space a little bit more reasonable. And now notice that I've got a couple different extents here. So this one is kind of zoomed in and these other two are zoomed out. And so notice that when I click on one, it activates that layer. So if I've clicked here and this becomes bold, and if I click down here, then this data frame becomes bold, and over here this data frame becomes bold. That'll be important for you to help identify which layer is which here. So I'm going to click here, that activates it, and that means that all these tools, these zoom tools, they apply to that. So I'm going to zoom out a little bit and try and get roughly the same size. And I'm going to square this out. And now I'm actually going to zoom back in, pull this out a little bit. So now I've got roughly the same size, and so I just need to decide how I want these displayed. And I might actually change my mind here and bring this back to portrait. Just depends on what you want to do aesthetically. You actually have free reign on how you want to arrange yours. So now I want to make sure that they're in the right order, and that'll add my map information. So we've got target areas here, and we have no treatment here, so I want to move that one up. And then this is our 2014 slopes. We'll move that here. And you guys can spend a lot of time moving things around. I'm just going to leave it pretty simple for now. So I'm going to start by adding a title. And this is going to be the title for the whole page. So I'm going to call this North REM Slopes Project, and click OK. And notice to get to that edit, I had to double click on this and it went to an edit screen. And I'll move things down. Now again, I'm not making my map the most beautiful, so you guys can get creative. And now I'm going to insert some text boxes. So there's the text box down there, really small. And so I will double click on this text box, pull it out here, and change the text to say no treatment. Now changing the font size here is a little more challenging, so I can't just change the font here, I actually have to change the size. And so this is a little bit of just a guessing game to see what size it might take. So I'm going to change the height, actually. I'll change the height to 3.3552 and just see what happens there. So that actually looks about right for my size, so you can kind of mess around with that. Notice that back here on the text tab it did change the font size. There's other ways to do this with some HTML stuff, but this is a way that works for now. So click OK. And move this up. I'll just move it here. And then I'll create another text box and do the same thing. And this also this off of here again, just so that I make sure I have the right one selected. Change this to 3, and then apply. And in the text, I want it to say slopes completed 2014. Click OK. And then another textbooks, and again move that off. And we'll call this one slopes target areas, and change the size or position to height of 3. Click OK. Notice that by changing the width, that would have just that wouldn't have made much of a difference, or it'd be hard to be consistent since they all have different amounts of writing in them. And now we want to add a scale bar. Now, scale bar might be a little tricky because theoretically each of these are zoomed somewhat to a different extent. So that's why zooming them to as close as possible the same is going to be your best bet, because you're not going to add a scale bar for each one of the data frames. You're just going to add it for one, and you want to make sure that it applies to the others. So we'll do insert, scale bar, and pick something simple. So this can go down here, and you can change how long or wide this is, and when you change how big it is, it changes the values here, and you can, if you want it to be short, then you might take out some of those breaks. You could double click on this and change the number of subdivisions and divisions. You can change the units that it's in depending on what your purpose is. So there's a couple different options there. Again, size and position. So you can manipulate that however you'd like. And then we'll also insert a north arrow. Over there. And the last thing we'll enter is our legend. And so we're going to use just one map layer, because again, theoretically our legend should all be the same. And the title would be legend. We can come back here to add a border if we want to, or background or drop shadow. And just more formatting information. So now we have our legend. And most of the time when we create a legend, there's some values that we don't really need. For example, we actually don't need it to say NTBP. And so we're just going to go here and clear that off for the time being so that we lose that in our legend. So to get, if you want to do non-aspect ratio changing, you'll have to go double click and then actually go into the size and position. You can change width and things here. If you, in the way that you are formatting your legend, want to make your legend over things here, then you might want to put a background color on it. So for now, this is what you are going for, and when you've completed your map in the way that you want it to look, you would then export your map into your lesson folder and submit that on BB Learn. So if you haven't already done so, now would probably be a good time to save this ArcMap project. I'm going to go to my Lesson 5 folder and save this as Lesson 5. Let's take a moment to review what we have done so far in this project and where we're going to go next. So again, to start with, you downloaded some land fire data so that we can understand what the current vegetation type on the landscape was. And then we used that landscape data as inputs into FlamMap so that we could say what the fire behavior might be under those vegetation characteristics and certain environmental inputs such as the fuel moisture and winds. And then we took that fire behavior output and we converted it into a form that was accessible through ArcMap. And using those outputs, we are now going to be creating interesting and informative figures so that we can understand the effectiveness of the fuel treatment options on the slopes area. Now, it's important to note that our fire behavior outputs that we got are made on a pixel by pixel basis. So for burn probability, it's not necessarily the burn probability across the landscape, it's the chances that that individual pixel will burn. And so it's useful to look at the landscape, but as we do our comparisons in more detail, we'll be clipping the area around those polygons of the treatments so that we can just analyze how the burn probability or the flame length or the crown fire activity changes inside that treatment area. Now for burn probability, we did our calculation and have made hopefully a very nice looking figure, and that shows us on this initial step the step-by-step burn probability or the treatment by treatment, and so we can look at that visually and see the difference. And then our next step is going to be to subtract the no treatment from the different treatment options, and so that we can see the change in burn probability. This change in burn probability is a super useful metric to see really where the biggest influences are and how that changes when we do have those different treatment options. So one more item to note is that this work that we're doing is meaningful and useful work, and the outputs that were produced last year by our students were specially requested by Casey Teskey, the fire ecologist on the Grand Canyon, so that they could be included in their report on the justification for this project. And so please do a quality job on not only these figures, but also the discussion that you produce on whether you feel like this project is effective. Now let's move on with subtracting the burn probabilities. So we will go to our project, go back to this data view, and I'm going to, since we're done using these, I'm just going to drag them down to the bottom here. And to make sure that this is the active layer, I'm going to right click and activate, so that now it's bolded, as you can see. And we do still have these other layers here, so that's good. So I'm going to go to Arc Toolbox and go to Spatial Analyst, and then Math and Minus. Input value here of no treatment. And our constant one is going to be this slopes 2014. And we will designate a folder here for our work. And we're going to go with our outputs folder here. Mine landed on the right one. Oh, no, it landed on lesson 4. So I will go to lesson 5, outputs, and I will label this NT for no treatment, and then also SL14, so that tells me it's no treatment, and SL14, and it's the burn probability. And then click Save, and OK. So our minus is now complete. I'll go back to my table of contents. The next step I'm going to do is make my other file. So I'm going to go back to Arc, and in my toolbox, go to Math and Minus, And this time I'm going to pick my no treatment again for BP, and I'm going to subtract that from my slopes target areas. And choose a location for that and name it NTSLTA, so no treatment, and then slopes target areas and BP, and click save, and then click OK. And I already have that created, so I'll just close this out. So now you'll have both of these in your table of contents, and so just like we did before, we're going to pick the one with the broader range, and we'll use that one to base off for the way that it stretches those values. So I'm going to change the color ramp here again, and I'm going to go with this blue-green color ramp and select OK. And now I want to go to my target area. So this target areas file is the one with the smaller range of values. So I'm going to right click on that and go to properties. And again, I'm going to import that color ramp that I used in the NTSL14. And click OK. And now again, I need to make sure that I'm adjusting my value, so I'm going to select my minimum maximum and check this box here, and then I'm going to change the values to match those that are in the NTSL no treatment on the slopes 2014 in the burn probability file. 0, 0, 7, 5, and this one's going to be to negative 0.007, and click OK. This is a bit of an update of this presentation, so the images as we continue on might look just slightly different from what we have here and what you might have. Okay, so now we can visually compare these two and see how they've changed. So let's look quickly at the numbers and think about what they might mean. To help us do this, I think it'll be useful to add our slopes completed and our slopes target area files so that we can see where these changes have taken place. So I'll add my slopes completed, and I will add target areas 2015 in the slopes planning folder, and I'll make both of these hollow, and one of them I'll make purple, and one I will make red. Alright, so we've got high values, which means that there was a higher amount of burn probability change, so there's a higher likelihood. So to think about this, we have to kind of break down what we actually did here. So we took our burn probability maps and subtracted them. So just looking at the burn probability map, we have a high burn probability and a low burn probability. So the low burn probability is always going to be 0, since that's the least that could happen, and a high burn probability. So there's areas here, just look at these. There's areas here that are more likely to burn, and there's areas here that are less likely to burn. And when we subtract two of these burn probability layers, then we get a difference. And the areas where there's a difference, a positive value, that means that's an area where the burn probability decreased. So if you think about starting out with a high number and then subtracting a lower number, you will get a positive value here. If you start out with a lower number and you end with a higher number, then you will end up with a negative number. So what you can see as you look across this landscape is you see that there are some areas, these green areas, that are lower, so they might even be in the negative values, and we'll look at this when we look at the spread of values. So why would burn probability have increased effectively in some of these areas? This is something that is actually relatively common when you change your fuel models, especially to fuel models that have a higher component of flashier fuel. So if you went from a timber fuel model to a fuel model that contained a lot of grass, then you're going to have a higher burn probability. So that in and of itself does not mean that you had an ineffective fuel treatment. It just means that you changed the type of fire that's on the ground. So then burn probability increasing isn't necessarily a bad thing, and so that's why it's really important to accompany with some analysis of flame length, because if you have a reduction in your flame length but an increase in your burn probability, then you have a better understanding that you just changed the type of fire that was there to a lower severity type of fire. So now, because we want to visually compare these two maps, we're again going to create a map in the layout view. So we'll go to our layout view here, and I've already started on this a little bit, but that needs a lot of work. So the first thing I'm going to do is I'm going to set up my data frames. So I'm going to have my data frame here. This is something I was working on before. I'm going to just remove this, and you'll have your previous data frames, and so you can delete the third data frame. You no longer need that. And I'm going to pull down these three layers, highlight them all using Control, and slide them down and put them in the new data frame. And now you have some similarities there. Remove this one. And so you can start to do your visual comparison. And so I had switched my view to landscape. Again, you can do whatever you'd like there, and make sure that turn this one off so that it's not showing up. And I will re-add my legend. And so for the legend, I actually want it to pull up just one of the ramps since they're the same, so that's fine. And I will click Next. Title's okay. And here's the legend I get. So there's a couple of things that would definitely be more useful to be called if I were to be presenting this to somebody. And so I'm going to delete values here. And it goes away over there. And I'm going to change the name of this layer to something that's a little bit more understandable. So we'll just call this change in burn probability. And I'm going to just add a date here. And I think I'm going to change the formatting on this a little bit and make it just a little skinnier so it doesn't make it so hard to see. And we'll have to do that on both of them. Then you can see underneath them a little bit better. So continue to play around with the formatting here, and then you will again be exporting this map and saving it and submitting that on BBLearn. So I'm going to take a second to save my project just in case something happens. So next we're going to be calculating area by flame length category and fire type. And this is going to be a really important thing to produce to compare, especially with our burn probabilities. So we'll go to our ARC project, back to our main slide here, and I'm going to turn some of these layers off and shrink them up again. and I'm going to go to Arc Toolbox and Spatial Analyst and Reclass and Reclassify. And we'll go to our first flame length file here. So we've got slopes 14 flame length, and value is our reclass field, and we'll click classify. And to start, we'll do equal interval, and we need 4 classes. And now I'm going to change this to manual so it stays as the 4 classes. Now I can adjust our numbers here. And so we're going to put this as 4, this one as 8, this one as 11, so this is in feet. And we'll leave this highest one the same and click OK. And for outputs, I'm going to navigate to my outputs folder, and I'm going to name this SL14 flame length, and I'm going to add an HC at the bottom, and the HC means hauling chart, and that means that this flame length has been reclassified with values from the hauling chart, which is this classification of flame length, the 4, 8, and 11 feet, that kind of helps us determine what kind of attack can be done on the fire if it has that kind of flame length. So we'll click Save there, and then we're going to set up an environments here. We don't need to classify our flame length across the whole area, and so we're going to go to raster analysis, and we're just going to be doing an analysis of flame length in the completed areas in 2014. Click OK, and OK again. And so we've had a successful reclassification. So now we'll go back to our Arc Toolbox, click Reclassify again, and I'm going to go next to my target area's flame length, and I'm going to click Classify again, and equal interval 4, manual, change these numbers again to 4, 8, 11, and leave that the same. Click OK, and change my output location. Call this SLTA flame length HC. Save. Now here on environments, I'm going to change this to the target areas. So it's just going to calculate the flame length for the target areas. And click OK. And OK. So again, successfully completed. And don't worry about the colors here, that's just randomly assigned colors. So now we're going to go to our no treatment. Now for no treatment, we're going to need to do 2 no treatment flame lengths. We're going to need to know the flame length in the slopes completed and the flame lengths in the target areas, and then we'll compare each of those files, the flame length of 2014 and target areas, to the respective no treatment. So I'm going to go again to reclassify, and I'm going to select my no treatment flame length, and there are a couple of error messages that pop up when you're doing this, but I haven't found them to interfere with the values that we get. So unique values cannot be obtained from raster. Just click OK. We'll go through the same process here, equal interval 4, manual, change this to 4, 8, 11, and leave that one the same. Click OK. And for our name, we're going to want this to be, I've named this already, so we're going to want this to be no treatment SL HC, and then label it 1-4. So that is going to tell us that this is from the no treatment over the area of the 2014 treatment area. So put that in there, and then in environments you're going to select the slopes 2014 as an area, and you'd click OK. And as that processes, you will end up with this layer here. So that's the no treatment area, and you can see that it matches up to the 2014. So now we will do that same calculation again, except this time with the target areas. So again, using our no treatment flame length, classify, equal interval, 4, manual, 4, 8, there we go, and 11. And you can see we have some pretty crazy numbers here. I'm just going to bring this down to the scale of the previous one, so I'll go to 390 for that, and click OK, and label this in my outputs folder NT underscore FL HC for hauling chart and TA for target areas. Click Save, and on environments, change the mask to target areas, click OK, and OK. And you'll notice with both of those that you end up with an exclamation point here, and that just says that there are some unrecognizable values in the higher end, and we're just going to accept that for now. And so we'll look at our tables here, and again we have these 4 different classifications, and it gives you the number of pixels in each of those classifications. So now we need to add a little bit more information to each of these attribute tables. So I'm just going to start with my first one here, right click, open attribute table, and I'm going to add a new column. So from my table options, go to add field, and I'm going to label this area underscore acres, or AC. And I'm going to change this to long integer, and that has to do with how long the values are that are going to be in that field. And I'll click OK. And now I'm going to calculate the area for each of these classifications of flame length. So we have done this before. We'll go through this again. So I'm going to right click here and select field calculator, and yes. And for my count, so the number of pixels that I have, so each pixel we know is 30 by 30 meters, and with the math that we figured out before, we're going to multiply that by 2.0002, and that'll give us the number of acres. So that many 2.002 pixels in an acre, and so that will give us the number of acres. And click OK. So now we have our acres here, so we'll do that for our other files as well. So now that you have your 4 tables calculated for area, you're going to be making a table to compare the values. So in following the pattern of the table here, you're going to create a table in Excel, and I'll just give an example here. So you'd have your flame length, and always include your units, so that's in feet, and then you'd have your no treatment, and that's acres. And no treatment, this is going to be for, actually we'll do a label on top of that. So this is going to be your slopes 2014, and this is going to be your no treatment, again acres, and this will be your slopes. Actually, I'm going to leave that name off, so we'll just have this be slopes here, and I'm going to make a broader category here. I'll make this bigger. So I'll merge this and call this completed 2014, and merge this and call it target areas. But I will add my units. And I'm going to extend, actually I'm going to wrap the text here. I can extend this out, and then you'll go here, so you have your classifications, and they're going to be the same as the ones that are listed here in the ArcFuels tutorial. And then you're going to get those numbers populated from the numbers that you have here in the table. So now I'll move on to step 2, which is to calculate the area in Crown Fire activity classes for all 3 treatment alternatives. So Crown Fire activity is a pretty important indicator of that fire behavior. And so to start, we're going to be using the Extract by Mask tool in the Spatial Analyst tools, so that we can clip the Crown Fire activity layers into the areas that they're representing that treatment for. Since again, we don't really need to compare it across the landscape, we are just comparing in those treatments. One thing just as a side note is that these fire behavior calculations, they're done on a pixel by pixel basis, and so they don't relate to the thing that's next to them. That's why it doesn't make a whole lot of sense to compare any of the information that's outside of the treatment area. So to begin, we will go to our Arc, close this out, back to Arc Toolbox, and we'll go to Extraction and Extract by Mask, and oops, I should have done right click here, and we'll do a batch. We'll just be doing 2. We're going to be doing the no treatment and then one of the consecutive treatments, either the target areas or the completed. So our input raster is going to be we're looking for things in the conversion results folder, so no treatment Crown Fire activity here, and this is going to be this is going to be the slopes 2014 Crown Fire activity, and the input raster or feature for clipping is going to be the completed and completed. And actually, it looks like we can choose different ones. So I'm going to go ahead and add another one here. And so we'll add our no treatment again. So no treatment Crown Fire activity. And this time, the input feature to mask off of is going to be our target areas, and then adding another one, we'll do the SL target areas Crown Fire activity, and again the mask for that is going to be these target areas, and then we'll need to select our output raster. And we're going to navigate again to our output folder, which is getting quite full. And I'll label this NT CFA and then C. Click Save. And OK. I'm going to expand this a little bit so we can see all of those files just to make sure that I'm getting in the right spot. And here we have, we'll label this one SL14CFA C clipped. Click OK. And here we'll have NT CFA. And again, I just remembered we needed to distinguish between the one that's clipped for the 2014 completed and the target areas. So this one will be our target areas. So we'll say TA and C for clipped. And I'll go back and change this one to 1.4. And then this one will be SL TA CFA for crown fire activity and C for clipped. Click Save. OK. And we'll click the OK button to start the process. So our extract by mask was complete. And we'll go to our table of contents. So now we have 1, 2, 3, 4 new files there. And so you can see that we're going to again make a column in each of those for area, and then we will create a table. And so there's 3 classes: surface fire, passive crown fire, and active crown fire, and fill in the number of pixels in each of those categories in each of our treatment types. So right click, open attribute, add field, so once that's complete, we will again be making a table with those values inputted. And so again, going to your booklet here, you will have your crown fire activity, and I'm just going to copy these cells here and paste them. And now I'm going to enter that information. So it will have our crown fire activity, number of pixels with each of that crown fire level inputted for both the no treatment and the slopes completed and the slopes target areas. So now you can, once this is all filled in, then you can take a screen capture of your completed tables and you can submit that for your question on BBLearn. So also included in the questions is some analysis of what these numbers mean and how they might be interpreted as far as the effectiveness of this field treatment.